Is it on? Yeah, perfect. Okay, good morning, everyone. How are you today? How was the first talk in the morning? Did you have a good one? Have fun? Yeah? Well, welcome to the second one. Welcome to immutable server generation. We're going to talk about some very interesting topic, or some topic that lies very close to my heart, immutability, and applying that at our servers. So a little bit about myself. I've been in the IT industry for a while, so these wrinkles don't come from nowhere. And I've spent a lot of time doing consultancy in the past, and out of that, I've always been involved into this space between development and operations. I've always found that there was something of a lot of efficiency to be gained around that, and a lot of problems were always appearing there. One of these problems was database migration. So a couple of years ago, I started the open source project Flyway. Who knows about Flyway? Okay, about 3/4 of you. Who's using it in production? Just for me, very interesting. Okay, we've got about 10–15%. Okay, great. For those who don't know what it is, it's a database migration tool to evolve your database schema along with your requirements. So I highly recommend that you use a tool to solve that. Whether Flyway is the right tool for you or not, that you have to decide. But to help you decide, there's a comparison matrix on the Flyway homepage of all the tools available for the JVM in that space. So pick the simplest tool that works for you. I'm also the founder and CEO of a company called Boxfuse, which we'll very briefly talk about at the end. But on to our main talk. So we do have a decent amount of material to go through. So I would like to ask you to hold on to any questions until the end, and then I'll do my best to answer them. So we make sure we don't overrun. And if there are more questions, I'll be around in the hallway as well after that. So. Enough about me, let's get to know each other a bit. So I would like you all to raise your hands and keep them up as long as the statements that are here are true for you. So, do you have an automated build? Everyone? Okay. Do you have unit tests? One hand goes down in the front. Do you have a CI server in place? Still, most of you. Okay, very much. Do you have acceptance tests that are automated? With Selenium or WebDriver, something comparable? Okay, still a decent amount, about 80%. Do you do continuous deployment of your code? We're about half, maybe, something like that. Do you also do continuous deployment of your configuration and database changes? Get about 15–20%. And do you deploy your infrastructure automatically? A couple of hands, about 10–15 of you. That's good. Okay. So how does this process typically work? Well, we've got our version controller, that's where things start, and then we've got our CI server, and at some point, whenever a change happens, the CI server is a bit like our neutral referee, and we'll make sure that that change actually works. So we check out the latest version of the sources, we build them, we test them, and we produce some kind of artifact. Now, the artifact we produce has a number of interesting qualities, stuff that we kind of learned over the years to be valuable. So we produce one immutable unit. Whether it's a jar file, a WAR file, a zip file, whatever we have, we produce one unit that we don't change anymore. We give it a version, and then it stays like that forever. We don't just unzip it, change a file, and rezip it. We don't do that. It's regenerated after every change. So whenever we commit something, we produce a new one. And we will then use the same artifact in all different environments to avoid the classic mistake of building a separate artifact per environment, which then leads, of course, to you running something in production that you haven't tested in tests because it's a different artifact. So we want the same artifact to evolve over all our environments. So, if we look at our software and the stack it's running on, it's actually like this. So we start from the hardware that's being driven by an OS kernel and some drivers that make sure everything's fine. We've got some basic libraries on top of that and our language runtime, in our case the JVM. On top of that we've got an app server, whether it's embedded or not in our app, doesn't matter, and then we have an application on top of that. And the process we've described so far really only applies to the top 2 layers in most organizations. And we should ask ourselves, well, why aren't we doing the same for the rest? Why isn't that going on? So, will there never be any problem in these other layers? So let's see. Let's look at some typical problems, and I'm going to ask you again to raise your hands if you've ever faced this problem in one of the other layers of the software. Have you ever had a server where there was some software missing or it didn't work as expected? So did I. Or something that was installed, but it had the wrong name, unfortunately, and then some reference could not be found, or it didn't quite work. Or it turned out to be the bad version, the old one that still had the memory leak that was still installed there, or the buggy one that was left and we didn't replace it. Or, of course, we are missing some essential permissions, we can't execute something, or something doesn't work, so that's a big classic as well, most of you. And of course, there's something like a port in use, and we cannot start something, so that's also very, very common. So we see that there are a number of problems that can appear there, and we really have to ask ourselves, well, if all that can go wrong, why aren't we holding the service to the same standards as our app? To understand that, we have to use a big time machine, and we're going to go back all the way to the 20th century. Pretty wild times, some of you may remember, we had this yellow guy there running around like crazy, and this was how you used to play music, and this was how you would rewind it. So it was pretty crazy indeed, and we had this guy. And this guy loved it when a plan came together. And when his plan was to get a server, this is how it worked. He got on the phone, the old style, with the cords and all that, and he called his good friend Michael, and he said, hey, Michael, I would like a server. And Michael said, well, sure, we can do that. And a couple of weeks later, a pizza box would arrive and would put it in the rack and screw it in and connect the power and the network. And then what? Still doesn't work. So we need to get back on the phone, and we call a young criminal from the western coast of the United States that gives us some criminal software, which we can then install, and we'll get it up and running. And from there, we then go on and start patching and updating an existing system. So what do we have? How does this model look like? We've got our RCI pipeline there. We've got our target system where we want to deploy. So we push our artifact to some artifact repository, and then eventually we pull it from there and we update the app. So it's actually not too bad when you look at this. It actually looks okay. Unfortunately, the reality hardly ever looks like this. It looks more like this. You have many machines in many environments, and they all need to be updated. And not just the app, all the layers of the system have to be kept up to date on all machines. So that's a big task. And who's normally responsible for that? That's our system administrator. He's responsible for making sure that everything's running smoothly, that the environments and the machines are as identical as possible to avoid any surprises late in the game. Now, let's turn to some wisdom. About 100 years ago, this guy was in the automobile business, Mr. Henry Ford. There's this famous quote, whether it's actually from him or not, is still open for debate, but the quote is still very good. If I had asked my customers what they wanted, they would have said, a faster horse. And this is exactly what we got in the IT industry. We got a faster horse, better known as the automated system admin and the configuration tools like the Chef and Puppets of this world that will basically do the same as your sysadmin is doing, just a little bit faster, a little bit more efficient, a little bit more reliably. Let's fast forward back to today. From the 20th century back to 2015, and what does the world look like today? Instead of going to Michael, this is the reality we live in. And it's unbelievable. This quote is now 15 months old, so it's probably even more now. But just let it sink in. The scale is just unbelievable of what we live in today. Every day, AWS adds enough server capacity to power the whole $5 billion enterprise Amazon.com was in 2003, weekends included. Again and again and again and again. It's just unbelievable, the magnitude. So, with this new reality, I believe it is time to rethink the faster horse. The first thing we can do is pull out our physical hardware and put in some virtual hardware. And we then have the possibility to start working with machine images instead of traditional artifacts. We can then push these machine images again to some kind of repository and deploy them on our virtual hardware as a whole. So that we get from a model like this to a model like that, where we just have machine images everywhere. If we build them correctly or intelligently, they're able to run on different kinds of virtual hardware. And the whole updates at the individual machine, at the individual node level disappear, so that we get to a model where the same machine image gets promoted from machine to machine, from environment to environment across our organization. But we have one big problem left. Our machine images and our network pipes, they don't fit together. The size of our network pipes has not kept up with the size of our machine images. So that machine images today, as we know them, are complicated to archive. It's not easy to archive thousands and thousands of versions of them per year. It takes a lot of time to transfer them. So that's not very practical. But once again, let's turn to some wisdom and let's see what that says. Running servers in production should be like going backpacking. You take the bare minimum with you, anything else is going to hurt. So this fantastic picture I took in the Alps about 2 summers ago. These 4 guys, they were just coming down from the mountain. They'd walked up 1,000 meters with their 20-liter keg of beer and the 4 big glasses and the hammer, and they drank it all in the one night, and then came back down. And I thought it was just fantastic. It's the total opposite of how you would do things efficiently, and that's actually how most of us run our servers. We kind of carry this huge amount of stuff with us, and we really have to wonder why. And so, if we're going to trim some of that fat, there should be a criteria to decide, and I think the criteria is what is actually adding business value in my server and what is just technical ceremony to keep ourselves happy, but not really to help our customers move forward. So let's put our machine image under the X-ray. And what do we have? We have a bunch of stuff in there. In reality, there's more, but this is just a little bit of a selection of what we have in there. So let's analyze each of these pieces and see whether we need them or not to solve our customer's problem. Our app, of course, we need. Otherwise, we wouldn't be there. But compatibility with old binary formats, 32-bit architectures, and other things, we don't need. It doesn't help our app, our customer. We need our app server to make our app run, so we'll keep that. But has a man page ever helped the customer? I don't think so, so let's get rid of them. Has apt-get or RPM ever been something our customers cared about? I say no, so let's get rid of the package manager. We're going to keep our language runtime because we need our JVM or whatever we choose to use to run our app. But do we need a C compiler on board of this machine? I say no. In 2015, do I want to open 5 different consoles and do tail-f of different log files? I don't think so. We've got fantastic solutions today, both on-premise and in the cloud, whether it's a Kibana Logstash combination on the one hand, or something like Splunk or log entries or some hosted solution somewhere as a service. So these guys will aggregate your logs, they'll make them searchable, you'll have a nice web UI to access them. So I say log files do not belong on the machine in 2015. If we don't have log files, do we still need an editor? Do I need a VI on this machine? I say no. Do I need all the other random utilities just hanging around there? No. If I don't have a VI, if I don't have these utilities, do I even need to log in to this machine? I say no, let's get rid of SSH. And if I can't log in, do I even need multiple users? What for? No, thank you. If the very things I set out to protect with my firewall aren't there anymore, why do I need the firewall? Let's get rid of the firewall. Do I even need the shell if I haven't got that? Do I need drivers for thousands of pieces of hardware when all I need are drivers for maybe 3 or 4 virtual network cards and other things? No, so let's get rid of the vast majority of our drivers. I'll need some libraries for my language runtime, but many other daemons lying around I can dispose of, and I'll keep the OS kernel. So that I'm left with the bare minimum I actually need to run my application and to solve my customer's problem. And when we bring all this together, when we fuse this together, we call this a bootable app. And we have a very different value proposition here. We are talking 40 to 80 megs. So all of a sudden, it becomes very easy to archive, very fast to transfer. So we have a very different world we live in. So a number of you are thinking right now about all kinds of scenarios where this doesn't apply. Well, it doesn't matter. Just use it for everything else. Wherever you have something like a 12-factor app or just a regular business problem that needs to be solved, you can use an approach like this. Because for every Facebook or special purpose problem, there are many more that are just ordinary and that just need to get the job done. And for them, this is a perfect solution. So let's see how this works out in practice. I've got, just to show you that this is live, I've got a small example web app here, so I'm just going to edit it. So you'll see that this is all brand new. So let's just say, good morning, JFocus. Up. Let's do exclamation marks. Save this guy. Just going to quickly rebuild it. A second. Okay, and what we're going to do now is to turn this WAR file into one of these bootable apps, and we're going to start it locally on VirtualBox. So to do that, we're just, in this case, going to use Boxfuse for that, and we are going to point it at our WAR file, and we're going to say run. So what's happening now is that there is some analysis going on about the type of payload that we're passing in. So we're detecting that this is a WAR file, so we'll have a dependency on some application server. Per default, Tomcat is chosen, and per default, the latest version is chosen. And so we've detected all that. We've then pulled in a JVM, we've pulled in a kernel, and a bootloader, and kind of put it all together in as we can see here, about just under 10 seconds on this old laptop. So it's about, it still has VGA, so that says it all. It's about 4 years old. So on modern hardware, it's about half the time. And we then create a new instance on VirtualBox and got a URL here. So I'm just going to copy paste this in the browser. So here we are. So that's our brand new app that didn't exist just a few seconds ago. And so if we look at what we've got running here, I think I still have a second one running from earlier this morning. But the newest one we just launched at 10:28 is just there, and that's under our URL here, and that's based on this bootable app over there. So let's have a look at what we've got there. So that's the 173 at the end. There it is. And so the total size of our bootable app here is 48K, and we can see how the instance booted as well by looking at the logs of the machine. So it's the same basically as the console if you were to sit physically at the machine. So let's go up a bit. So here we see we kind of start, and then we get an IP address, and then we kind of summarize what's on board, and then this is a standard JVM plus Tomcat kind of starting, and there's our app. Okay, now Matthias sent a little email to the speakers that said they shouldn't rely on the network. So that's exactly what we're going to do. We're going to deploy this on AWS right now, and we're going to choose. You are going to choose whether we do it in Ireland or we do it in Brazil. Who would like it deployed in Ireland? Okay, a few people. Who would like Brazil? All right, off we go, to the sun. Okay, so I'm just gonna quickly grab the ID again. And because we don't want to rebuild it, we want to reuse the same image. So we're gonna run it again. So this time I don't specify a WAR file, I just pick this guy here. We are going to switch the platform to AWS, and we are going to switch the region to South America, East 1. Off we go. So please don't start downloading all kinds of stuff on your phones right now. This is there is no net here, so we'll see a risk of falling. But okay, the bandwidth's doing all right. So you've been kind, thank you. So we're almost there. So basically, what happened now is that we took our image unchanged. We kind of stuck some AWS specific descriptor on it and uploaded the whole thing to S3, the storage service of AWS. And then we asked their infrastructure to kind of register it as a machine image, which they've done. And they've assigned us an ID here. And now basically they're scrambling and they're running through the data center, trying to find a network cable to plug in and all that. So they're in a bit of stress right now, but in a few seconds they'll be ready there. And what they've done for us already is they've created a security group. So that's a bit like an external firewall. We just kind of say what kind of network traffic is allowed to reach the instance. And we've gotten an ID for our instance as well. So here it is. And now we're basically waiting for an HTTP 200, which we've received right now. So let's look at this IP address here. Just copy paste the guy. Open a new tab, paste it. Here we go, and that's basically our app that didn't exist before, that is now running identically on VirtualBox and on AWS in Sao Paulo. Thank you very much. Okay, all nice and well, but we do actually, this brings in, it causes a bunch of changes if you start working like this. And the biggest one is really that you have a shift in focus. The focus shifts from an individual server or an individual instance onto the service. It is really now important that the service stays available, whereas the server itself is something that is disposable. Whenever you're done with it, you can get rid of it. Whenever a new version comes, the old one just dies. So that basically we move from a model where instead of treating our servers like pets, we start treating them like cattle. So who's ever given their servers a name? Well, we're going to move from this to that. So far, so good. But the minute a new version comes, do you know what's happening to our kitty, our cows, I mean? Unfortunately, yes. So we can just hamburger them. Once we don't need them anymore, off they go, they are disposable. And it's actually a good thing. It's a good thing because for a long time in our industry, we used to pride ourselves of incredible uptimes for our machines. It's been running for 2 years. And the problem is, it's a huge source of stress. Because if this machine ever needs to be recreated, if there is ever a failure of some sort that causes us to need to set it up again, good luck. So, that's our machine itself, But we're not alone, of course, and we have to use a bunch of stuff. So, for example, a database, how do we deal with that? In a world like this, well, there actually nothing changes. You can connect to your existing database like it is before, or you can use some kind of hosted service, and there are many right now, whether it's on Amazon RDS, Google Cloud SQL, on Azure, there's lots of possibilities to have it hosted, or you just run it yourself as you've done before. If you need to migrate it, of course, small shameless plug, you can use a tool like Flyway, but as I said, any tool there is better than no tool at all. We talked about our log files. TL-F should be banned in 2015, I say. So again, we have some very good services you can connect to right now. Logentries.com, papertrail.com. There are a number of hosted ones, or you can run your own with Logstash, Kibana. There's a bunch of possibilities there as well to have all that set up. The main point is the logs do not belong on the instance. You ship them out to a central place where they're aggregated, they're made searchable, and you've got a nice UI to actually work with them. Another interesting bit, our sessions. Who has sticky sessions on their systems right now? Are there different? Okay, about half of you. There's a bit of a problem with that, of course, if our server dies. And that's, so we, in the past, we've then developed some schemes where you kind of start replicating the sessions amongst the different nodes in a cluster, and then we kind of discovered that generates too much traffic, so you kind of elect a peer with whom you're going to replicate the session, and you don't replicate with everyone anymore and all that. But still, you're still kind of stuck with something suboptimal. And so, surprisingly, we've been lagging a bit behind the other platforms here in the JVM space. But this practice here, putting the session in a cookie, is actually commonplace in ASP.NET, in the Rails world, in PHP. It's been done for a while as well. And so, so in the JVM space, this is still fairly new to a number of people, but it brings you a lot of advantages. There are some filters that are ready that you can put in to your application, so that you don't, from a programming point of view, you don't even see the difference. But what this brings us, putting the session in the cookie, first of all, we get rid of our sticky session problem. We can start farming our machines. But also from a capacity perspective, all of a sudden we only need to provision enough RAM for the sessions we're actually actively processing right now, not the ones that are just open and just dormant, because all that is being sent to the client instead. So the client has that, and just when something comes in, do we need the memory to deal with that. The session, of course, can be protected through encryption and through, and you can sign it cryptographically to make sure it's not being tampered with. So that's actually the main recommendation. If it doesn't work in the cookie for some kind of reason for you, you feel uncomfortable about the amount of data being there or whatever, you can always ship it out to the back as well, to an in-memory cache or in the database if you must. Okay, so we've got different bits and pieces coming together. If we see, we've moved a bit to, I like to call it infrastructure like Lego, where you can kind of click the different bits and pieces you use together based on what you need. And that's very, very useful, but how do we deal with our application itself when it comes to updating it? And when we've got the hamburger process going on, as we saw, how do we deal with that? Well, let's have a look at it. We've got our application here, and the typical scenario, you would address it through a load balancer. So a request comes in, forwards it to our application, which can then forward it to some kind of database, collect some data, send it back. And so in a modern world of the cloud, how does that work? There's a concept of an availability zone, which you can think of as a single data center somewhere. And you can then have a second one, geographically distant from the first one, so that you then, in case of disaster, make sure your service stays up and not the individual instance. And you deploy a replica of the application there on the second availability zone. You can, of course, send your logs to some centralized service somewhere, manage this for you. Session goes in the cookie, as we've seen. When a new version of the app comes, blue-green deployment. We leave the existing infrastructure as is, and you put the new version next to it. You then verify whether it's healthy or not, and when it is, you start sending traffic to it, and you decommission the old one so that you can then have an update process with zero downtime along the way. So, let's summarize. we have seen that we have, in our CI environment, produced a certain deliverable that is one immutable unit, whether it's a jar file, a WAR file, what we use today, that is regenerated after every change, and that we then promote from one environment to the next to avoid the classic mistake of building it anew for every environment. And we apply those principles to the remaining layers of our stack for what we call a bootable app. You can implement these principles yourself. I'm a strong believer that this is the way forward for our industry. So, or if you are on AWS, you can sign up for our public beta, which we're going to launch later this month. But that's up to you, whatever you choose to use there. And that's all I had for this talk. So thank you very much. Any questions? Yes.
Can you tell me about the difference between Docker and yourself?
The question is, what is the difference between Docker and Boxfuse? In my opinion, Docker are very much trying to establish themselves as a platform. So they have a number of things that they're bringing in the game. So they have their platform layer, they have their standardized format, the images, and then at runtime, the containers. And I see them very much going as a competitor for VMware, for Xen, for the traditional layers there to replace all that. Boxfuse takes a different route. You're able to use your existing infrastructure below, and we just kind of have a flexible format on top that we can adjust for whatever infrastructure you have below that. So it's I think that's the primary difference. I think Docker brought some very interesting things to the table as well by saying, okay, we forfeit the hardware isolation at the CPU level between our different containers to gain some performance. So that's an interesting thing with some interesting trade-offs as well. If you trust your neighbors, it's great. If you don't trust your neighbors, it's not so great. So that's why everyone in the public cloud will box a Docker container in a VM as well to avoid having your direct competitor try to invade the kernel and get into to your image there. So that's that's how I would compare it. But we can talk more at length afterwards if you want as well. Yes. So the question is, there are some differences between environments. You do not want the same database for production and test, so how do you deal with configuration? All the available hypervisors and cloud providers today let you pass in some data when an instance starts. So you can then use this data for whatever purpose you want. And in the case of Boxfuse, we use it for letting you define environment variables. So you can pass in key value pairs, they then get exposed as environment variables, and then your app can deal with them how they want, so they can then read them out. But I would say this is only the second choice. If you can choose, I'm a big proponent of actually baking the configuration as far as possible directly within the image for all the environments. And then deciding at runtime in which environment you are, and picking the set of configuration you need. And so that is a decision that you can base on some kind of algorithm of IP address ranges or host names or whatever, or passing in a single property that says you are in production, and then you pull the set of production configuration properties. But yeah, that's yes?
How do you build the AWS AMI? Do you use Packer or something similar, and what OS do you use by default?
So 2 questions. How is the AMI built? Is it built using Packer or a similar tool? And the second question is, what kind of operating system is being used? So how is the AMI built? It is not built using Packer. The standard Boxfuse format simply gets translated directly to an AMI. So there is no, you don't need to spin up some kind of base AMI and do other things. It's just direct, straight to AMI. What kind of OS is being used? there's a Linux kernel, not much more. So there is no traditional distribution as you would know it in a regular image. Yes?
Would it be possible to use Boxfuse in corporate environment from our own servers, say VMware or something?
So the question is, would it be possible to use Boxfuse in a corporate environment? We are running a private beta right now for VMware with the first enterprise customers, but it's something we only plan to commercialize broadly later, just because we still need to learn gain some experience there and sort out the challenges. But that's definitely part of the plan, because for a corporate environment, there are some very interesting benefits from a density perspective, because you do not have infinite resources, and so being able to pack more onto your vSphere cluster, onto the existing resources, does bring a lot of benefits there. So that's definitely something we're exploring, but it's going to be widely available further down the road, not just yet. Yes?
Do you have something for service discovery so you can find each other?
How do you do service discovery in this world? How do you make sure that services can find each other? There are a number of solutions for that. My favorite one in the AWS space is that each service is fronted by an elastic load balancer, and then you just need to remember the host name of the elastic load balancer, and that kind of scales automatically for you and will then serve the nodes that you have behind that. Otherwise, you have services like Console and a bunch of tools that help you solve that problem as well, but I find the elastic load balancer solution quite elegant. Yes?
So I'm wondering how big the container or virtual machine is that you're running on. Was it VirtualBox or is it more close to LXC? Or?
So this was, it was running on, locally it was running on VirtualBox, and then AWS, of course, on the Xen. And, well, the whole machine there, including the whole JVM and everything, was about 48 megs in that case, most of it being taken up by the JVM. Yes?
Very interesting talk, Axel. Have you got any thoughts on how Boxfuse relates to emerging frameworks like Mesos, Kubernetes, and Atomic?
Sure. Do I have any thoughts how Boxfuse relates to Mesos, Kubernetes, and well, I think again, Mesos and Kubernetes right now are their primary market is the enterprise, and they basically are there if you have lots of machines in your enterprise and you want an easier way to just deal with them as one pool of resources. And so that's definitely a goal that's a bit different from what we have here. So I would say the jury is still out of that. I don't have a deep enough first-hand experience with these tools to be able to comment more, unfortunately. Yes?
Well, since your server images are immutable, I'm sitting here thinking that you could probably pretty easily create a diff file or something more clever than that, and like use it to say, here's server A, apply this patch to that image and copy it to server B. Is this something you're experimenting with, or is it?
So the question is, if the servers as a whole, if the images are immutable, what about binary diffs? Could you just send a binary diff and then apply it to this server or that server and just work with that? It is something that I've not actually explored. It's a thought I've been having as well, but the AWS infrastructure as it is today works very well with entire images, because then you can tie into their auto-scaling groups and all the rest, that they provide you a lot of nice things there, and so it's not something that's on the immediate agenda to kind of explore that avenue further. But it is certainly an interesting topic, and certainly once we go in the direction of on-premise, I think it's something that will have to be explored to see if it adds the value we would hope to get out of it. Yes?
In Boxfuse, how do you configure the image? Like, if you want a specific Java version, you want to import supervisor, how is that handled in Boxfuse?
So the question is, how do you configure the image if you want a specific Java version, or if you want to install supervisor or something else. So two answers to that. The first one, if you want a specific Java version, a specific Tomcat version, or some of the components that are on board there, you just specify it. So there is a repository comparable to an apt-get repository where there basically all the different versions are stored, and then by default it selects the latest one, but you can pin it, which we highly recommend, so that you have something very stable and you can upgrade at your own pace. So you can pin exactly which OpenJDK version you want, which Tomcat version, and so on, and then that's just there. So that's just a key value pair thing in the config. Now, if you want to install other tools on there that aren't part of the standard build, this is not something that's supported at this time. Maybe later, but not at this time. Yes.
How do Boxfuse make money?
That's a fair question. So the development is free, and so is one application on AWS, and that maps with the free tier of AWS, so you can get started completely for free. And if you want more apps, if you want more versions of your apps stored remotely, then there are different pricing tiers between 25 and 200 US a month. Yes, one more.
When you deploy it to AWS, can you sort of auto-register to a load balancer or change the name of the security group? So what kind of options do you have?
Yes, so you can, there is zero downtime upgrade integration with load balancers. So basically you add, how you would usually do it is you would work through auto-scaling groups as well. So you would create an auto-scaling group, a second one next to an existing one, where you say, I want a capacity of, let's say, 2 images or 2 instances, and then you register that with, you check that all these instances are healthy, and then that gets registered with the Elastic Load Balancer, and the other one gets deregistered, and that happens automatically for you. And then you had a second part for your question. The name of the security group is also simply a property you can set. So per default, it will create a new one based on the port configuration that you've passed in or that it's detected. So in this case, just port 80. But you can also specify your own. If you want to, for example, tighten your security and make sure that only the load balancer can send requests to the instance, then you can just specify your own. Okay, if there are... oh, yeah, sorry. The question is, are there other alternative solutions? Yes, it's actually a space that's very busy. There's lots of stuff coming up. There are some guys in the Valley. They have something called OSV. It's also for the JVM. They've taken a slightly different approach, even though the result of the image looks similar to what Boxfuse does. They've decided to re-implement their own kernel. So they don't reuse the Linux kernel. They have their own stuff that only runs in the cloud. So that's an interesting thing. Then there's the whole unikernel movement where you can really compile your code into something that into really just one binary, not a mini image, but really just one binary that runs on Xen and other things. And there you have stuff like a Mirage that's written in an exotic language called OCaml, and you can then link it straight to the core and then make it start right there. So there is definitely stuff moving in that space as well, and other things to keep a lookout for. Okay, if there are no more questions, I thank you very much. I do have some Flyway and some Boxfuse stickers here to hand out if you want. And we are running a course about continuous delivery and zero downtime upgrades and what you need to put into place in your architecture with JFocus on Thursday and Friday. So if anybody is still interested in that, I think it's still possible to sign up. Check with Matthias. We have some seats left. Otherwise, thank you very much and have a fantastic day.